Okay. So now let's review what we know so far. We are still in our motion/forces unit. And you know motion means for an object to move from one place to another over time. You also know that you can calculate speed by dividing the distance it travels by its time. You can even find the distance and time of that object if you're given those other options there, okay? Then we have velocity is the exact same thing as speed, but it has direction, okay? If velocity changes in any way, then you are accelerating. And accelerating is more than just going faster. You could be going slower or you could be changing direction as well. Now, on Monday, we talked about these different graphs. We realized that when we're talking about position versus time, that the graph is basically only telling us the direction it's going, whether it's moving forward or backward or not at all. But when we get to graphs of velocity, we have more information. We know if something's moving forward, if it's above the origin, backward if it's below the origin. And what we're basically looking at is a changing in speed over time. Is it not changing? Is it increasing or decreasing is what we're looking at. Acceleration is very similar. Again, above the origin, moving forward, below the origin, moving backward, and then is it increasing in velocity, decreasing in velocity, or not changing in velocity at all? Okay. Questions on any of these graphs before we talk about Newton's first law? All right, so you should have all of those notes already. Now we're going to add to our notes, add to our knowledge, and we're going to add Newton's first law of motion. It's also known as the law of inertia. Clicking raise your hand. Any volunteers want to share with us what they think Newton's first law of motion is? What is Newton's first law of motion? Don't all volunteer at once. How about in the chat box? Oh, thank you, Sanal. Go ahead, Sanal. What do you remember about Newton's first law?
That like an object won't move unless some force hits it, and if it's in motion, then it will keep going in motion until a force stops it.
Beautiful. Anybody else want to say it differently or want to add to that? Okay, so when we have this here, I have a couple examples for you here, right? We have this little glass guy and he's in motion, but unfortunately there's a force that stops that motion. Otherwise he would be going on and on and on. Now you could be at rest and you are going to stay at rest until something forces you to change it otherwise, okay? So we have to have both in our description. An object will remain in motion and an object will remain at rest unless an unbalanced force acts on it. Just like this cat, you can raise your hand in your camera. How many of you are like this cat in the morning? It's really hard to get out of bed. Yeah. Oh yeah, most of you. I could tell you this morning that both my boys did not want to get out of bed. They did not. And in fact, it took a lot of force to get them out of bed. They were at rest and they wanted to stay that way. I had to turn on the lights. I had to pull their blankets off of them. I had to literally yank the little one out of bed, like drag him out of bed. I had to apply a lot of force to make them change what they were doing. And they wanted to stay in bed all cozy. I think tomorrow I'm going to get a squirt gun or a spray bottle, and I'm going to apply even more force, okay? Because I was like, we got to go, come on. And I had to, oh my God. No, they would not get out of bed. They were at rest and they wanted to stay that way. I was the force though. No, we got to get going, right? Now, that's also inertia. They were resisting a change in motion. So inertia is when you resist that change in motion. My boys were like, heck no. And in fact, my little one was fully wrapped up in his blanket, like burrito style. And I had to literally pull that blanket off of him. And he was resisting so hard. He had a lot of inertia this morning. Ooh, ice. That would be fun. I'm going to tell them, Ian, that you told me I could use ice. Okay? So, now, the more mass you have, the more inertia you have. Okay? So, if we notice this elephant versus our little stick guy here, the elephant is going to resist a change in motion more. You can't make that elephant move, little stick guy. Are you kidding me? Okay. But this little stick guy is running, and it's really easy to stop him. Okay. So when we have a less mass object, it's easier to change their motion than it is a higher mass object. The more mass you have, the more you're going to resist that change. I'm just grabbing my charger, sorry. Okay. Kind of like some of your drawings. Some of you drew this big ball on the edge of the hill. Now, if you were at the bottom of the hill, would you want that rock rolling down to be as big as the elephant or as tiny as our stick guy? Chat box, what would you rather do? A humongous elephant-sized boulder or something like our little stick guy? There we go. Again, this is in the chat box. Wake up, fifth period. You can do this. Your last class, most of you. So you're at the bottom of that hill. Most of you are going to pick the tiny stick guy because he's going to be easier to stop. Okay, he has less mass. If you have a big old boulder coming at you at the bottom of the hill, woo-wee, okay, that's going to be a lot harder to stop. All right. Go slower or go faster in the participants box? Only 5 of you that clicked in. Some of you like a challenge. All right. It's really hard for me to gauge if I'm going too fast or not because I can't see your journals, okay? So please let me know if I'm going too fast. So go slower or go faster in the participants box. Okay. I have 11 of you are saying go faster. Excuse me, that's only a third of you. All right. Now, 8:20, 11:22, beautiful. So I've increased how you can participate in class, okay? I've added some of our discussion questions on your formative. So let's say you're not really comfortable unmuting yourself and talking in front of the whole class. I still expect you to participate through the formative, okay? So my first question for you is, what devices do we use to measure time? So go back to the formative. This is going to be number 2. Or again, I'm recording your participation on my clipboard, or you can hit, let me clear, the raise hand icon and just share with me. What's a device we use to measure time? Ian, can you give me one?
Clock.
Clock. Thank you, Ian. Naomi?
Stopwatch.
Stopwatch. Thank you. John?
An egg timer.
Egg timer. Thank you. Sanal?
Your phone?
Phone. Okay. Lila?
An alarm.
An alarm. Thank you. Gia?
A watch.
A watch. Thank you. Anybody else? All right, let me look at what you wrote on formative. So it's okay for you to do it typing wise on the formative. It's okay for you to raise your hand and answer verbally. It's not okay to sit there and do nothing. Okay. Question was, do we answer in complete sentences? Nah. This is just participation, right? So I see alarm, I see watch, clock, phone, timer. Let's see if I see anything different. Ooh, somebody mentioned a sundial. And let me see, there was one more that my last class brought up. What's it called? The thing with the sand in it? I know there's a
Hourglass.
There you go, an hourglass. I wasn't, thank you for that happening here. Okay, so now I just put a couple images, right? Stopwatch, somebody mentioned an egg timer. What units do we use to measure time? So again, you can raise your hand, or now we're on number 3 of the formative. What are some units that we measure time with? I've heard from these 3 folks already. Is there any new voices that want to participate? Sharon, can you give me one?
Seconds.
Seconds. Thank you, Sharon. Kaylee?
Minutes.
Minutes. Ashwarya?
Hours.
Hours. Gia?
Days.
Days. Naomi?
Decades.
Decades. Ian?
Microseconds.
Microseconds. Bryce?
Years.
Say it again.
Years.
Okay. I've heard from Sanal. Did you share yours?
Weeks.
Weeks, right? So it has to be about time. Oh, Naomi wants to say more. Hold on, Naomi. Let me look at your formatives now. I see milliseconds. I see seconds. I see minutes, hours, days, weeks, months, years, decades. I see centuries. I even see microseconds. Good job. Okay. So now we're going to talk about forces though. So what do you think we use to measure force? This is now number 4 on the formative. So you're either writing on the formative and or you can raise your hand. Ian, what do you think?
Protons.
Louder?
Newtons.
Okay, newtons. What else? I'm a big fan of wild guesses. What do you think? Give me some wild guesses. Bryce, what do you think?
SL units.
Can you say that again?
SL units.
Okay, thank you. Anybody else? Wild guesses? Wild guesses. Okay, so ignore the next question. What we use to measure forces is what's called a Newton scale. Okay, this is one way to measure force, and that's how we're going to use it in our class today. It's literally like a spring, and I have a few examples here for you. If we were in class, you would be using these, and I'm kind of sad that you're not here, okay? And it has this little hook. I don't know if you can see the hook, sort of white paper. Okay, there you go. So we can see the hook on there. And as we hang stuff on the hook, there's this little arrow, and it's going to pull down the heavier it is. You might see these in grocery stores. They used to have like hanging baskets. You might have a scale that measures your weight at home, or you go to the doctor's office and they measure the weight. But their scale is going to be a little bit different. It's not going to be measuring in newtons. Since we are in the United States, we use the English system, and they're going to use pounds to measure your weight. If we were using the metric system, we were using newtons. Now, I don't know if you can see this, but on the actual scale, again, it's really hard, frustrating, is a newton, okay? So what I want you to do, oh, time, yes, okay? I'm gonna go back here. So I've already sort of talked about it. Anybody wanna remind the whole class? What are the units? I'm gonna clear the hands. What units do we use for force? For time, you guys said seconds, minutes, hours. What about for force? Naomi, what about for force?
Pounds.
Pounds. That is one of the units we could use. What else could we use for force? And I'm not sure if you can see this on your screen. There we go. It's easier to see. What do you think that capital N means? Sydney, what's that capital N?
Newtons.
A Newton. And so we are going to be measuring forces in newtons here. Okay. All right. It's time for us to take a break. And then I'm going to demo using a Newton scale for you. Okay. So go ahead. We have 3 minutes and I need to pause. So we just used our Newton scale, and I just finished demoing. Sorry, I didn't record it. But what are some other forces you know? I gave you weight already is a force. So now on number 7 in the formative, you could be filling that out. Or you can click raise hand. You are not allowed to just sit here and do nothing though. So you have to do one or the other. You could do both if you want, but you are not allowed to sit here and do nothing, okay? Elijah, Annabella, are you guys back from break? All right, so now you're filling in the formative on number 7. Ethan, what's another force you know?
One force would be applied force.
Applied force, okay. Sanaa, what do you know?
Friction.
Friction is a force. Any other forces you know? Do you know any words that have the word force in it? Give you a little hint. I'm reading your formatives and I see applied force. I see friction. I see pushing. Good. I see weight. Oh, I see tension. I see air resistance. Good. What other forces do you know? This is not working. All right. Sanal, did you want to add something?
No.
Okay. All right. So I don't want you to so much worry about the individual forces, but know there are two categories of forces. There are contact forces and there are non-contact forces. Okay. So a contact force, many of you mentioned that applied force, meaning you actually have to make contact with something, okay? It could be a spring force, it could be drag, which many of you said air resistance is a form of drag, frictional force or friction, and one that you normally don't think about is normal force. I'm looking at your cameras right now, one of you is sitting down, and you don't think about you're pushing down on that chair, but at the same time, that chair is pushing up on you. And that's the normal force, is that chair pushing up on you. If that chair didn't push up, then you would be flat on the floor, okay? You would break it. Then there's those non-contact forces. Magnets are fun. Hopefully you've had experience playing with magnets. You bring the magnets together, they attract or they push against each other. Electrical forces, just raise your hand. How many have ever shuffled your feet across the carpet before? Oh, yeah. And then you build up all this charge, right? Chat box, who do you normally go touch? Who do you normally touch? You build up all that electricity. And if you have any brothers or sisters at home, yeah. Oh, your poor dog. Oh, no. Usually you torture your brother or sister or maybe some cousins. And if you build up so much charge and the lights are out, sometimes you can see a spark. Kind of fun. Try it next time. Okay? Or whoever used that I told you. Okay? So, and then of course, gravitational force. Faster or slower? Faster. All right. So last thing before we actually do our activity. Ooh, see, Jaden's even adding more static electricity. And I so wish you guys were here. I would, anyhow. A wool blanket, if you have like a really scratchy blanket or something with more surface area to give you more electrons. I like that idea, Jaden. Wear a blanket and shuffle around with the blanket around you. Cool. You could see sparks, yes. I once shocked somebody on accident and I've seen like the electricity transfer from one to another. It didn't feel good, it hurt, but it was cool to see. So little little tidbit. Okay, so now our last thing. How would you, oh, your poor cat. How would you define a force? So go ahead, our last one, stay with me. Number 8 on the formative. And I even put some pictures here to help guide you. Okay. Any volunteers that would like to share what they think a force is? Raise your hand. Man, you guys are my quiet class. I see a lot of you using the formative. Maybe it's just one of those days. All right, let me hide the names and I will share the screen. You guys are making me do all the talking. It's not very fair, but we're here. Some of you said when you kick, it's a push and pull, a certain power, energy, when there's a connection, a physical action, strength or energy. A lot of people are saying push or pull, changing an object's position. Okay, those are all good options. The definition for force is fairly simple. A force is simply a push or pull. That's it, push or pull. So the moment you push or pull an object, you are applying force. This morning, I literally had to pull the blankets off of my boys, literally pull the blankets off of them. I applied a force, okay? Oh, I didn't talk about inertia, right? And my 5-year-old, I literally can pull him out of bed, no problem. But my 8-year-old is twice his size. I can try to pull him out of bed, but it's a lot harder. He resists that change a lot more. He has a lot more inertia. I would need to apply a lot more force to pull that guy out of bed than my little 5-year-old. Okay? Questions for me? All right. So, let's go ahead and take our break early, and then you guys can have the rest of the time to finish the activity. So 3 minutes, get up, get some fresh air. So now we get to play. We have a PhET simulation, and this PhET simulation, I put the link in the chat box for you. And it's also on the Google Classroom assignment. So go ahead and open that up. And just a show of hands. Am I doing this right? Yep, let me change the way I'm sharing it. Just a show of hands, how many have ever played tug of war before? Okay, so you know, we're gonna start with the net force. So when you open up this simulation, we click on net force. Let me return everybody, we reset, okay? So we have a little tug of war situation going on here. And when we look at your worksheet, it's going to tell you step by step what you need to do, okay? So again, we want to follow the directions here. So you have 3 experiments. The first experiment is with just the blue team. The second experiment is the red team. And then the third experiment, you're going to then have a competition, okay? You're going to have one team win. You decide which one. And then your second time is going to be a tie. So all you need to do is follow the directions, and then you're going to answer the questions there, okay? I do want to point out a couple things though. We do want to utilize this green box. So you do want to click all those boxes because it gives you more information. And I want you to spend the first couple minutes literally just play. Just goof around and play around and see and hit go and see what happens. Play around this way. Add people. What happens if you take people off? And just play around with this before you get started. So go, and then when I want to reset, I just hit this orange circle thing, but I have to remember to click on those green boxes again. Okay, so go ahead, play around for a couple minutes. And then you can start on the questions. Okay, all right, I'm going to stop recording.